Hello, statistics and pre-calculus. Today we're going to be continuing learning about inverse functions. And today specifically, we're going to be finding the inverse of a linear function, then graphing that function and its inverse. So this example can be found on page 270. So here's our problem. We're going to find the inverse of f of x equals negative 2x plus 3. Then we're going to graph it here on this plot. So first thing that we want to do is get this in a form that makes us more comfortable solving it. So instead of using f of x, we're going to use y. Y equals negative 2x plus 3. Our second step is to isolate x or solve for x in terms of y. So to get x by itself, we need to get rid of this plus 3. We'll subtract 3 on both sides and get y minus 3 equals negative 2x. Then we simply have to divide by negative 2 on both sides. So we get negative times the y minus 3 over 2 equals x. And then we can further simplify this down to get y, negative y, plus 3 over 2 equals x. Now, all we have to do is flip our y and our x back again. So we have y equals negative x plus 3 over 2. And finally, instead of putting this as y, we're actually going to change it back to our inverse function notation. So we get our answer. The inverse function is negative x plus 3 over 2. So here is our answer. All right, now we simply have to graph, which is the easy part. So first, we're going to find our y-intercept by setting x equal to 0. So our y-intercept, f of 0, equals negative 2 times 0 plus 3. So since this term goes away, anything times 0 is 0. We get our y-intercept is 3. Now, to find our x-intercept, we're simply going to set y equal to 0. And luckily, we already have this function in term of x, which makes this a little easier for us. So we're going to have x equals negative 0 plus 3 over 2, or the x-intercept equals 3/2. So let's go ahead and plot this here. Our y-intercept is 3, and our x-intercept at 3/2, or 1.5. Then we can simply draw a line between them. So we get a graph like this. Now, we just have to do the same thing for our inverse function. So remember that an inverse function is basically a reflection of our original function over the y equals x line. So what we can do here is simply flip our inverses. So instead of our y-intercept being 3, our x-intercept is now 3. And instead of our y-intercept, our x-intercept being 1.5, oops, I put that at 2, didn't I? 3. And now, instead of our x-intercept being 1.5, our y-intercept is 1.5. Then we can simply draw our inverse function. So this should go between my lines are maybe not perfect, but you get the picture. And so we get this nice function. So again, red is our original function, f of x, and our inverse function reflected over the y equals x line is the inverse function. So that's how we do it. So our next video, Mr. Fisher is going to talk to you about how to verify that we actually did find the correct inverse.